The topic of my talk is JavaScript to PureScript. It's mainly about my experiences and journey from JavaScript into a more functional language. I'm really a beginner functional programmer. I don't have expertise, and I don't understand how F and AF works and other things work. But I'm trying to puzzle, piece together all these things so I can actually understand FP better. So the title of my talk should more be less like JavaScript to Elm to PureScript, because Elm was basically something which actually got me really addicted to functional programming. So JavaScript as a platform, it's everywhere. You can actually see it on your desktop, on your mobile phones, on your servers, even in your databases. And thousands of companies use it. It has thousands of libraries, frameworks, pretty much anything you can think of you want to do has a library in JavaScript. But JavaScript as a language is a very different story. And I will let you be the judge. I'm not here to criticize JavaScript. I'm just here to explain why I wanted to move. So to demonstrate, I got a few examples from Gary Bernhardt What talk. It was done in 2012. So let's have a look at some examples. So in a normal language, if you think that, yeah, hey, I'm going to add an array to an array, you'll actually think that it will return me an empty array. In this case, we have two empty values. JavaScript returns you empty string. That makes sense? It could be that they're just empty, so how about we try with an array which actually has real values. So it's like, in this case, I'm assuming that it should actually return 1, 2, 3, 4, 5, 6. But let's see what JavaScript actually gives us back. It's like, that's a string as well. And it's missing a comma. So it's like, hey, why not? OK, so this is getting too complicated. How about we actually try to do an operation which shouldn't be possible in most of the languages? Say we actually add an array to an object. So any guesses what will actually be? Empty string. So JavaScript returns it back as an object. So this is actually kind of a better way of representing something, and not just an empty string, so it's good. How about if we just switch the operands around, right? The plus operation is the same. All we are doing is moving the array to the right and leaving the objects on the first. So JavaScript returns us 0. It's like, hey, this is just awesome. So by this time, my brain was like, I need to just leave this thing aside. So it's like, hey, give it one more try. Let's just do an object plus object. Like, what should it actually return? It's like, yeah, it should return an object. That's like, hey, not a number. And this is actually right. It's actually not a number, which is kind of good. So I was left in this dilemma. I really want to, all of my clients, all of the work I've been doing, people want JavaScript. But for some reason, I was having a hard time working out all the kinks in JavaScript, and my brain doesn't, my brain is not that big. I just need to think of things in a logical way and how I can use them. So I started looking into some functional languages that compile to JavaScript, and I was like, hey, why not? So surprisingly, there are pretty much all good languages compile to JavaScript. And I think one of the reasons is that JavaScript is very good as a platform, and it has been successful. So here you can actually see ClojureScript, we have Elm, we have PureScript. We also have a Haskell port, which is JC, which actually compiles Haskell to JavaScript. Reason is kind of new from Facebook, which is like an OCaml dialect. And then we have Scala.js. And there are plenty more. They're just everywhere. It's like, OK, so what should I do? So it's like, hey, you have to choose, but choose wisely, right? I don't want to invest time. Learning a language it takes a lot of effort. You want to be good at something, right? So you actually take a lot of time, and you put in a lot of time, and then you say, OK, I want it to succeed, so I want to bet on a winning horse. So it's like, OK. For me, basically, I had one criteria. I work with Ruby every day, and it's dynamically typed. And it's like, yeah, I'm just tired of dynamically typed and nil errors and stuff. I love Ruby, but that side of things, I don't really want to deal with. So how about I choose a strongly typed language, and as well as it will give me something to work and learn, and it will also make, it will take away the pain of JavaScript. So I chose Elm. And there is a reason I chose Elm, and the reason for basically choosing Elm was that they promised never to mention the M word. And I was really, really scared of monads, monoids. It's like, what the hell? What are they? And everyone just keeps telling them, like some people say burritos, some people say, no, they're not burritos. It's like, yeah, make up your mind and just tell me. And I was like, okay, I cannot deal with this thing. I just need to get my hands wet. So it's like, what can I do? So like say, okay, so somebody said that Elm is basically a gateway drug to functional programming. It's like, okay, that sounds good. So what are the pros? So what really sold Elm to me was that it was really, really simple. I actually got up and running in like a week or two, which was just brilliant because I was like, hey, this is going to take me ages. But now I was writing my first application within a day, 2 days, 3 days, and a week I was writing some libraries. Very helpful error messages. So anyone who's actually going to try Elm, like they actually do give you very nice error messages which say that, yeah, do this and it will work. Instead of just saying, hey, blah, 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 blah. It's like, you don't know what's happening. It had very simpler types. So it introduced types to me, or the type system to me, but in a very gentle way, which was actually really good. And the Elm architecture. So this was one of the biggest things. So they actually tried to solve an issue. Like, you don't have to worry about effects. You don't have to worry about how those effect libraries actually come into play and join together in the main world. You just have to follow this architecture pattern, and we can actually make sure that you have a way to deal with side effects nicely. And that was really, really useful. But then I got better at Elm. And then it's like I just started seeing things which I didn't see before. So one of the things is Elm is very, very simple, but it actually comes at a cost. And the cost is basically the power. So you don't have any type classes. You have a very limited JavaScript interoperability. No server-side support, so you can't write Node.js apps and stuff like that, which is one of the things I like to do because most of the time I'm actually writing backend apps and not front-end apps. And the Elm architecture. So if your app doesn't actually fit the Elm architecture, it can also be a curse. So I was like, okay. So I was almost ready, like I wanted to know more advanced types. So it's like I was just here, and I had a crystal skull in my hand, and I was like, hey, I need to know advanced types. It's like, okay. So it's like, tell me, I'm ready. So I jumped into PureScript. And PureScript, like, the philosophy is very simple, a strongly typed functional language which is inspired by Haskell. And I was already reading the Haskell book on the side, so it made much more sense to actually jump into PureScript and see what's this about. So let's actually have a quick look at what PureScript is. So how to install PureScript. This is not a PureScript tutorial. I just want to give it out there that it's actually very, very easy for you to get started and up and running. Like if you have NPM, you can just do npm install PureScript. It will give you the main language. You get a couple of tooling options, which is basically Pulp, which is their project management, or directory management thing, and Bar is basically for handling packages. So to create a new project, you just create a new directory and just go Pulp in it, and it will just create a scaffold for you, which is very easy. Then you can do Pulp build, and it will generate all the things you need. And you can do Pulp run to run whatever's in your main code. So what does it actually generate? So it generates something like this. So it has like basically module main saying that, yeah, this is the main file, and I need to import some of the libraries which you're going to require, and then your main function. And the main function is basically the entry point to PureScript. So in here, main, I'm just saying log, and I'm going to say hello sailor. And that is the same thing you're actually seeing on the left-hand side, where I do pulp run, and it says hello sailor. So it looks very simple. It actually looks a lot like Elm, because Elm was inspired by Haskell as well. So why PureScript? So I was thinking about it for a long time, and the reason I actually started liking PureScript is basically they don't have any runtime. And we'll go through this in a bit more detail. They also compile to a very human-readable JavaScript, which is actually surprisingly good and makes your life so much easier. It also has a very powerful JavaScript interoperability, and that was one of my main criteria to choose PureScript. And it has an advanced type system compared to Elm. So it has type classes and higher kind of types, which is kind of good, and we'll touch them later on. So what do I mean by no runtime? So you can actually write a PureScript code. So in this case, we actually write a code saying, hey, we have a module main, and this guy just actually defines like my name, which is pretty much like a constant, right? Because the name is actually fixed to Marvin. So if we actually see what PureScript actually compiles this down to, it literally has my name, Marvin. And it's exported as a CommonJS module, so it has no runtime library requirements and stuff like that. It only needs what's actually required to run your program. Let's have a look at some more examples, right? So human-readable JavaScript code. So the code we showed on the last slide was actually quite readable. But what about some more complicated examples, right? So in this case, we actually have a function called add. And add takes two numbers, and it joins them like adds them together, and returns it back. So like if we actually compile this down to JavaScript, it looks something like this. And this is actually quite readable, right? Like you actually have the add function, which is the same name, and it actually takes a function which takes one parameter, and it returns another function which actually takes y. So basically, everything inside PureScript is curried by default, so all the functions. So this is just mimicking that curry behavior. So it actually takes a function y, so if you actually call it with 1, it will return a function back, which is waiting for another argument. So this is quite readable. Like I actually really like it, so I can actually see what PureScript code is actually doing. How about we actually go a bit more further? And in this case, we are actually going to do, we're going to define like a sum type. And the sum type basically is nothing like, nothing new or inventive. All it's saying is that action can have 2 values. It could be an increment or it could be a decrement, and nothing else can actually come into the action. So action is a box with just 2 values. So when you open up that box, you can actually choose that value, and then you can perform operations on it, right? So the next function we have is show action, which actually takes one of those action data types and say, okay, if I see increment, I'm going to show this, and if I see decrement, I'm going to show this. So it's basically just converting into a string. So, and converting this into like JavaScript, I thought this will be more complicated. But surprisingly, it actually returned with this. Now, the code might actually looks weird because of my fonts. But the idea is that it actually converted increment and decrement into functions. And it actually created a show action, which is a function itself. And of my pattern matching, which was happening on the left, when it was saying, hey, if show action had increment, just show that increment string, it's just doing if. It's using if to do that pattern matching. It's still quite readable. I can actually read this code and actually figure out what's happening without actually looking at the PureScript code. So which is kind of good. So all these things aside, like readability and stuff is good. It's no use to us if we can't really operate or interop with the language itself. So to do like calling PureScript within your JavaScript code is actually very, very easy. All you have to do is, we'll go back to our same example again, which is add. Once it's compiled down into a main.js file, like it actually just uses the name of the module to actually compile the file down. You can require main, and then you can just call the functions on it. So main.add, and you can pass 1 and 2 because it's curried. You have to do it twice. And similarly in browser doesn't actually have CommonJS, so you actually get a PS, which is a namespace, and the namespace actually contains your module names, and you can do the same thing. So it's very, very easy. So this is only from PureScript to JavaScript, but where the real power of PureScript actually comes down to is basically getting JavaScript code and moving it into PureScript and making sure that the code is actually, side effect free and it's actually well behaved. So how can we do that? So let's start with a very, very simple example. In this case, we actually have a JavaScript file called main.js, and it has this function called hello. And all this hello function is doing is that it's prepending hello in front of a variable, which is like a name, right? So how can we actually expose this inside PureScript? So in PureScript, you actually get this thing called foreign import. And all you do is you say, hey, foreign import, and you use the name of the function you exported, which is hello, and you say, I'm going to give it a type. And the type's going to be, it takes a string, and it returns a string. And now PureScript actually knows that, okay, this function, I need to pass in a string, and I can actually return a string back. I'll get a string back in return. So you can use this thing in your PureScript code anywhere by just using that name of the function. So you can just do hello Marvin, and it will actually return back to you hello Marvin. But this is a very small thing, right? Like it's not complicated. Like you can actually do this in other languages. But like PureScript actually provides you a much better way to do JavaScript interoperability. So let's look at something more concrete. In this case, we are actually looking at a set item. So I want to do a side effect. Basically, I want to set like a key value pair inside the Windows, sorry, not Windows, the browser's local storage. And the browser local storage, basically, if I'm setting anything or changing anything, I'm doing a side effect, and I might not actually get the same result back. So in this case, I actually call a thing called set item, and it actually takes a key, and then it actually takes a value. And then it actually performs a side effect, which is wrapped inside a function. So how can I represent something like this in PureScript without breaking PureScript? So you can do that by introducing an effect. And what you can do is you can actually say, hey, I'm going to import this thing called set item. But this set item is going to take a string and then another string, which is the key and the value. And then it's going to perform an effect. And I'm not really sure like what that effect's going to be. So I'm going to wrap this in a type. and the value of it is going to be a unit. So unit, basically, you can think of it that you can actually use it as a discard type, right? It's universally just one thing. So it's like, yeah, if you're not doing any particular operation kind of thing, you can just denote it by unit. So, and you do that, and that's it. Like now you can actually use setItem in your code wherever you want, wherever you are doing stateful operations, and it will actually call the JavaScript code underneath. But going further, like this is not introducing us to the concepts of types and stuff, and we are like, what about if we actually read the value back? So if you actually read the value back, you can actually write the same function, but it's like this reverse, so saying get item. And this time, we are actually saying, hey, I just want to read the item from the local storage. Now, for any of you or like who have actually done JavaScript programming, if local storage doesn't have this key, what will you get back? Undefined? Yeah. So undefined or a null value, right? So how do you encapsulate that in PureScript so the PureScript functions can actually reliably use that data set? So you can actually you can use more effects. So you can actually define a foreign import saying underscore get item, and underscore get item basically has an effect which actually says, hey, I might actually get a nullable string back. So I'm not confident that I will always get a string back. So it could be a null value as well. And then on top of that, that's why I use the underscore get item, because that function is a private thing which I want to interact with. But then I actually want to introduce a new thing called get item, which is actually a PureScript representation, which under the hood just converts the get item into a maybe. Right? So like for me in PureScript land, I'm just going to use get item and not worry about it. And the get item actually returns a solution, which is basically saying it's a maybe string. So you're taking something which is impure and have side effects and can have issues, and then you're converting it into your PureScript. And this is very powerful. Like this abstraction is very, very useful. Because what you can do is you can actually just take apart your JavaScript library one piece at a time and introduce those functions into PureScript and just keep reutilizing them again and again. Okay, so this gives us like better libraries, right? Like this actually gives us that, okay, we have all these libraries in JavaScript, but we cannot use them because the state management is kind of shit. There are issues with the JavaScript language itself, and we can't trust them. But what we can do is we can make sure that we can actually port these things into PureScript or a language something like this, which can actually give us a bit more better type system and clarity on things. So these are just few libraries, right? But if we can't find any of those libraries inside PureScript, that's fine. And this is what I did. And that's why I actually really like PureScript, because I was going to work on a library called Rethink, and RethinkDB is like a database, and it's quite new, but I wanted to play with it, and it's like, yeah, there is no library in PureScript, and I'm still learning the ropes of functional programming, so I'm not that great to actually write a whole new library for Rethink. I was like, okay, NPM actually has already a Rethink library, which is an official client, so I just picked it up, and I just started tearing it piece by piece and importing it back into PureScript, which is really, really useful. So for libraries and stuff, you can actually use this tool called Pursuit. And Pursuit is basically the documentation tool. You can actually search for different kind of libraries. It's also similar to Hugel for people who are aware of Haskell. Basically, you can actually search for types as well. So you can actually search for things and it will actually return you result. You might not be able to read, but it's basically, the expression is basically A to B, which is like a function, and then it's saying, hey, I'm going to take A, and then I'm going to return the type of B. So it's like a map. Okay, but this is where, this is all good. Now you want to do front-end applications, then how can you actually do? And Elm is very, very popular, and this is where my journey started. So I wanted something which is very easy for me, which makes it easier for me to transition from Elm to something like PureScript. And we did that using Pux. So Pux is basically a framework, and Pux is written in PureScript, but the ideology of Pux actually comes from the Elm architecture. So if people who are familiar with Elm will actually know that, yeah, you actually have an event, and that event will actually generate a state, and those states and event can be passed into your HTML to generate the new world, and this thing keeps on happening in a loop. So you can actually build type-safe web apps, which is really, really good. It also does things like isomorphic routing and rendering, so like server-side things. It has hot reloading. It also renders to React, which is also kind of amazing. Because of this JavaScript interoperability, they have been able to just consume and use libraries which are already out there. They don't have to reinvent the wheel. They don't have to write their own rendering or DOM manipulation library. They can just say, hey, React is already solving all these things. I can just use that. It also has a time-traveling debug extension for people who like Elm, like me. So let's have a look at Puck's architecture, right? So Puck's application basically consists of 2 types and 2 functions. So your 2 types is a type for your application state, which could be, in this case, just an integer, which is type state on the second line. And the second type is of the events or the actions your application can actually handle. So in this case, basically, it's a sum type. Again, it's an increment and decrement. And then you have 2 functions. One function is to render the view of how you want to represent that state on your browser. And the other one is to actually take events from that view and do something. So in this case, it's fold_p. And all it's doing is it's doing an increment and raising by 1. And it's doing a decrement that's decrementing it by 1. And that's it. And then you actually have the main loop, which is basically saying, OK, yeah, I'm going to take my initial state, which is 0. And I'm going to take my view, my fold_p, which is the function to operate on these things. And I'm going to take my inputs. And that's it. That pretty much generates you the whole app. And this app is basically responsible for handling all the button clicks and stuff. And you can actually just click, and it will pass it to the fold_p with an increment or a decrement. And then it will actually generate the state, and it will render it back to the thing again. So which is very, very useful. And it's very similar to Elm. It is so similar that if you actually look at Puck's and Elm code side by side, they actually pretty much look the same. So you do have the state, which is model 0 in this case. You do have the event, which is like a message, increment and decrement. You have the update function, which is fold_p in our case. You actually have the view, which is similar to our view. And that's it. And the main body actually renders the whole thing. So which gives you a very nice way to actually move your Elm apps into PureScript if you want to. But it doesn't stop there. Because PureScript is a general-purpose language, they haven't really restricted you to just using the Elm architecture. You can do anything you want. So there are other libraries. So we have this library called Flare, and Flare is actually based on FRP, which is basically, being stopped used. So Elm is not going to use FRP anymore, at least not in the front. So this is kind of the thing. So it's like the language people are making the choices for me, which makes it very hard for me to justify that I will keep using that language. Whereas PureScript is more on a community basis, that the community needs something, they will actually work on it. So Flare FRP. So basically this library is basically a general purpose, a specific purpose UI library. And all it does is that it actually tries to define your user interface and the logic together. Now, it has limitations, but at the same time, it actually gives you such a remarkable expressiveness. And you can actually look at it. So this is pretty much the same function like the one we were looking at previously. This is just incrementing one number. But because Flare binds your button, which is basically the view, to the function, which is fold_p, to increment it, it will actually give you results like this. So you can actually just express that whole increment thing in 2 lines. And that's it. And it actually knows how to iterate on previous values, and it will keep adding things. But it doesn't have to stop here. You can actually do more complicated things. You can actually do things like this. So this is basically color slider. So you can actually choose, based on the hue scale or the RGB scale, you can actually choose. And the sliders will actually represent the color what they actually form. And the whole library is actually quite simple. It's really, really concise, and you can actually look at it. So if you want to create widgets and stuff using PureScript, you can actually do that quite easily, and then export it into a main file or a widget file, and just include that widget file in your JavaScript code, and that's it. So anything complicated which you want to do in JavaScript, you can actually do in PureScript and just export it out as JavaScript. But why stop at Flare? So you have other frameworks. So you have Thermite, which is basically just a wrapper on top of React. So people who are familiar with React can actually just use Thermite to represent the React classes and components and just use that in PureScript. You also have things like Halogen, which is a declarative type-safe UI library. And it's being used in one of these big projects called Slam Data, which uses Halogen under the hood, which is awesome. So why PureScript? Why did I move to PureScript? And the reason is simple. It's better abstractions, right? In languages which have type classes, right? You can actually represent things which you can't do otherwise. You can you cannot create something like, so say if you're waiting for a list of AJAX requests to complete, right? Or you're waiting for a list of form tables or form fields, or you're evaluating a list of nullable values, right? All of these could be like represented as a traversable. Now, in NPM or in Java land, right, JavaScript land, you'll have to keep doing the same thing. Anyone who has to implement traverse, they have to go again and again and again and again. It's just duplication everywhere. But whereas with type classes, you can actually say, hey, I'm actually going to create like a traversable type class, and it's going to have a common implementation, which is going to be used pretty much for all the other systems which actually wants to use traversable. And this actually gives a real power, right? Like, so then you can actually say, hey, so all these things were actually list of items, but what about streams? What about arrays? What about trees? Like, I can actually still use traversable to actually make them useful. And this is very, very useful. To give you an example, so this is like a very basic type class. And the reason I really like it now is because it was restricted. Like, I could not find this in Elm. So once you actually had your hands tied, then you start exploring, and then you start realizing, okay, these things actually are very useful. So in this case, we actually have like a show type class, which actually just have one method, which is basically show, takes anything which is A, and returns a string value for it. So if you want to implement that for a Boolean, basically Boolean, you say, hey, show true should actually be represented as true string, and false is false string. But you can do more things. You can actually do like show array. So an array can actually have, okay, I'm going to represent an array, and I'm going to map over each of the values, and I'm going to concatenate that and just show it together. But the thing is that you don't know what that A is. That A could be something which doesn't actually have a show on itself, right? But you can actually restrict it. So after show array, I'm actually saying that A has to have a type class of show. So it will only be implemented for a thing or A which actually has a type class on its own. And this is a very powerful abstraction, which is FP all about. Like, I mean, the more I learn, the more I say or more I see is basically abstractions give you a power which you can't get otherwise, which is awesome. PureScript also has better tools. So they have been very focused on developer happiness. So they actually have things called PSC IDE, which is basically an editor integration. So it can actually tell you errors and stuff, and it can actually fix them on the fly. It also has type-directed search. So what do I mean by type-directed search? So basically, in PureScript code, you can actually say $help. And the idea behind $help is that, hey, I know this part of my code, but I don't know what kind of type actually fits there. So can you find me something? And the compilers are clever enough nowadays, right? They can actually figure these things out. So PureScript can actually give me an answer back of saying, hey, after looking at your code, these are the things which I think suit you. And fold will actually work. So if you actually put fold, it will actually do what FizzBuzz actually does, and yeah, about your uncle. So this is like very, very useful. So compilers actually give you all these powers, so why leave them? So yeah, better techniques and will lead to better FP. So PureScript has this ideology of saying, hey, Haskell has pioneered all these things. Why can't we just take it from Haskell and improve on it? And play around with more ideas and more things. So they introduced something called row polymorphism. They are working on new playgrounds for testing. They're also working on different backends. So PureScript just does not compile to JavaScript. It compiles to Erlang, and it compiles to other few things. But you can write your own backends as well. And in the meantime, you can actually learn how they're actually doing all these things, which is really, really useful. So where from here? I will recommend these two books. PureScript, by example, actually has all these topics about FP and examples about them. And then if you get stuck and you really want to read more, the Haskell book is really, really good. And basically, it helped me understand how monads and applicatives actually work, which is really, really useful. And resources, you can actually use Pursuit, which is for documentation and finding libraries. Thank you.
Thank you, Rahul. Maybe we'll have one question, so almost right at the time.
How do we bind PureScript to UI styles?
To UI styles?
Yeah. So, like, do they map to the classes, or do I have to bind my styles to HTML elements?
So that depends on the DOM library you actually will use. So
Okay.
PureScript DOM actually has the concept of A, which is A.attributes, and classes, so you can actually just bind those classes as normal and full generate the classes thing as
You have
normal.
to choose a DOM library.
Yeah.
Okay.
Yeah, otherwise you have to render something, right?
Yep.
But those DOM libraries can be, yeah, like, you can write your own as well, so. Thank you.